Imagine a place in space where gravity is so strong that nothing can escape, not even light, the fastest thing in the universe. That place is a black hole. It's like the ultimate cosmic vacuum cleaner. When a giant star runs out of fuel, it can collapse under its own weight. This collapse creates an incredibly dense point with immense gravity. This is how a black hole is born. Anything that gets too close to its edge, called the event horizon, is pulled in forever. It's a one-way trip into darkness. We can't see black holes directly because they trap all light, but we can see their effects on nearby stars and gas. Now let's flip that idea on its head. Imagine a place in space that does the exact opposite, a place that nothing can enter. This is a white hole. It's a purely theoretical object, something that exists in the math of Einstein's equations but has never been seen. A white hole is like a cosmic fountain. Instead of pulling things in, it violently pushes things out. Matter and light can burst out from a white hole, but nothing can ever cross its event horizon to get inside. It's a one-way street, but in the opposite direction of a black hole. It's a source, a beginning, a constant explosion of stuff into the universe. So we have these two cosmic titans. One is the ultimate consumer, swallowing everything in its path without a trace. The other is the ultimate producer, spewing out matter and energy with unstoppable force. The black hole is a point of no return. Once you're in for good. The white hole is a point of no entry. You can never get in, no matter how hard you try. They are perfect opposites, two sides of the same cosmic coin, described by the same powerful equations of general relativity. One is an ending, the other a beginning. Thinking about these objects gets your mind racing, doesn't it? Black holes are real. We have found them. We have even taken a picture of one's shadow. They are a fundamental part of our universe's structure, shaping galaxies and the destinies of stars. White holes, however, remain a beautiful and fascinating mystery. They might not exist at all, but in science we love to ask, what if? So let's ask one of the biggest what ifs in cosmology. What would happen if these two cosmic opposites were set on a collision course? The universe loves a good show, and this would be the greatest of all time. Let's look closer at what makes these two cosmic objects so different. The key difference is the direction of time, in a way. For a black hole, everything flows inward. Its event horizon is a surface that only allows things to pass through in one direction, into the black hole. Think of it like a waterfall with no bottom. Once you go over the edge, there's no climbing back up. The future of any object that crosses the event horizon lies inside the black hole, crushed into an infinitely dense point called a singularity. It is the ultimate cosmic trap. A white hole is the mirror image of this. Its event horizon also allows passage in only one direction, outward. Nothing from the outside universe can ever cross into a white hole. It's like trying to walk into the blast of a rocket engine. The force is always pushing you away. For a white hole, the past is the singularity inside, a point from which everything continuously erupts. It's a source of matter and energy that has been spewing out for all of its existence. It's a cosmic ghost, a memory of a singularity that keeps giving. So the black hole is defined by its ability to trap you. The white hole is defined by its ability to repel you. The black hole's event horizon marks the point of no escape. The white hole's event horizon marks the point of no entry. This fundamental opposition sets the stage for a truly mind-bending encounter. One object is a perfect sink, the other a perfect source. One is all take, the other is all give. It's an irresistible force meeting an immovable object, but on a cosmic scale where the very fabric of space-time is at stake. This contrast is what makes their potential meeting so fascinating. What happens when a region of space that only allows inward motion meets a region that only allows outward motion? Do they cancel each other out? Does one win? The laws of physics as we know them are stretched to their limits just by asking the question. We are venturing into the unknown, using our imagination to explore the most extreme possibilities that the universe could offer. This is what science is all about, pushing the boundaries of what we know. Picture this. A black hole and a white hole are drifting through space, drawn together by their immense gravity. As they get closer, the black hole, the great devourer, tries to do what it always does. It tries to pull the white hole in. Its powerful gravity warps the space around the white hole, attempting to swallow it whole. But the white hole is not like a star or a planet. It's a region of space-time that, by its very definition, cannot be entered. It is a wall of pure outward energy and matter. The moment of contact would be unlike anything else in the universe. the black hole's event horizon tries to expand and engulf the white hole. At the same time, the white hole's event horizon is a boundary that violently rejects anything from the outside. So what gives? It's possible that the two event horizons would meet and merge in a chaotic, unstable dance. The matter constantly spewing from the white hole would be immediately captured by the black hole's gravity. It would be like a fountain pouring directly into a drain. This process could lead to an incredible spectacle. The collision would be a zone of pure conflict. The white hole would be spewing out matter and energy, and the black hole would be greedily consuming it. This could create an unbelievably bright and energetic display. We might see a massive flash of gamma rays, the most powerful form of light. The two objects might orbit each other for a moment, creating powerful ripples in spacetime called gravitational waves. It would be a cosmic battle broadcast across the universe. Eventually, one of two things might happen. One possibility is that the black hole wins. It keeps consuming the energy from the white hole until the white hole has nothing left to give, and it simply evaporates or vanishes. Another, more dramatic idea is that the two objects could annihilate each other. In this scenario, the region of inward-only spacetime meets the region of outward-only spacetime, and they cancel each other out in a flash of pure energy. The result would be no black hole, no white hole, just a huge explosion that would be the most energetic event since the Big Bang itself. So what can this wild thought experiment teach us about our universe? Even though white holes are only theoretical, thinking about them forces us to confront the biggest questions in physics. It pushes the boundaries of Einstein's theory of general relativity. Are there really places in the universe where time flows backward, or where matter can be created from nothing? Exploring these ideas helps scientists look for holes in our current theories and find new ways to understand the cosmos. It's like stress testing our knowledge of reality. This cosmic clash also connects to the idea of wormholes. Some theories suggest that a black hole and a white hole could be two ends of the same tunnel through space-time. If you fall into a black hole, you might, just maybe, pop out of a white hole somewhere else in the universe, or even in another universe entirely. In this view, the collision isn't a battle, but a strange kind of self-destruction. The two ends of the wormhole would meet and close the tunnel forever, releasing a tremendous amount of energy in the process. Ultimately, thinking about a black hole meeting a white hole reminds us how much we still have to learn. The universe is filled with extreme objects and mind-bending possibilities that we are just beginning to imagine. We have our equations and our theories, but the cosmos is under no obligation to be simple or to make sense to us easily. Ideas like white holes and their collisions are a playground for the scientific imagination. They encourage us to ask bold questions and to dream up new ways of looking at the universe. And that is the true beauty of cosmology. It's not just about what we know. It's about the thrill of venturing into the unknown. It's about looking up at the night sky and realizing that it is full of wonders we haven't even dreamed of yet. The clash between a black hole and a white hole might be a fantasy for now, but it's a fantasy that sparks our curiosity, fuels our quest for knowledge, and reminds us that in the grand cosmic story, we've only just read the first page. Keep looking up.